Hello and welcome everybody to the worst podcast ever. I'm your host, Alex Wykoff, the Director of Product Web3 at WRSTCollabs. And today we're going to talk about the merge. This is our pre-merge podcast. We only have a few days left to go before the merge happens in the Ethereum ecosystem. And I'm greeted with my guest, Matt. If you would, Matt, please tell the world about yourself.
Hi, thanks for having me. I'm excited to be on the podcast. Hopefully I won't make it even more worst than it already is. Just kidding. So I'm Matt. I'm a co-founder and CTO of a company here in Austin, Texas called 236. We build Web3 NFT things for clients. That's the best way to describe it. NFT sales, platforms for marketplaces. If you have a brand, if you come in, we can build you a website to sell, mint your NFT. We generate artwork, pretty much everything A to Z.
Excellent. Well, it's so good to have you on the podcast here, Matt. I was kind of curious if we could, I'd love to dig into your background just a little bit as it relates to crypto. You were saying that you're the co-founder of 236. How long have you been operating in the cryptocurrency space?
Yeah, so 236 as a company actually has been around since 2018. It started out as kind of a side business, but not until the end of last year did we really start digging into Web3 sort of things. We had a client come in our door that wanted a NFT project done, and they said, hey, have you ever done anything NFT related? And at the time we really didn't, but we took it as an opportunity to figure out about the ecosystem, and that was our first NFT project. It was with a company called Super Plastic. We did their janky heist drop and sold plenty of NFTs through Shopify, which was actually the first time that Shopify had ever done NFTs through their platform, which is really exciting too. So got to do a couple first with that project. It was also a project that took crypto and fiat. So now you can actually go to Shopify. There's an application that you can add to a store that allows you to take both, and we were some of the beta testers for that. So a lot of
exciting.
Yeah, it was really cool. Really nerve-wracking. You know, there were some times where it was just me and our CEO Alex at the very beginning, and like lots of late nights. We were trying to really get things off the ground. We were both working 2 jobs at the time. So that was kind of like our tipping point where, you know, we really felt like we had something whenever the project was super successful. So learned a lot of things, kind of, you know, feel like we pioneered some things in this space too, which is really cool.
Mm-hmm.
Felt like we sort of made a name for ourselves, and kind of like the proof that came out of that was, to this day, we still don't do any advertising, all word of mouth, all the connections that we make. So still some people that come through our website to say, hey, you know, we saw that you and Super Plastic did that partner with Gucci or with Bored Ape Yacht Club, and how successful it was. So that's how we actually get a lot of our clients today.
Absolutely. I was just about to say, I think Super Plastic is a pretty well-respected name in the space at this point. And the fact that y'all were with them almost from the very beginning is really an exciting thing to hear about.
Yeah, it's crazy. I honestly, if you would have asked me like even a year and a half ago, that I'd be working on NFTs and, you know, doing these sort of drops and stuff like that, working with Super Plastic and Deepak Chopra, that was somebody that we even collaborated with. I just wouldn't have believed it. I'd be like, I'd be doing what now?
Yeah, totally. You know, I think that often when I talk about NFTs and their relationship to cryptocurrency as a whole, I call them the tip of the iceberg that's above the water. And the thing that I really am hoping for us to dive into on this particular podcast is to actually go to the whole opposite end of the iceberg, so to speak. And so I was kind of curious, you know, what is your level of comfort with Ethereum? Obviously, you've been building NFTs, but have you played much around with spinning up a node or a validator or anything to this extent?
Yeah, so for a lot of our projects, we have to use Infura, which is kind of like a copy of a node that you can reference. Lots of APIs, Moralis being one of them. For a project that we're looking into recently, checking out QuickNode, which is just another service that you can essentially copy a node and query the blockchain that way. Yeah, as far as spinning up a node, I'm interested in potentially doing node validation or doing a node validator with Ethereum 2.0. And I think we'll probably talk about it, but there's, there's still a couple of risks involved and stuff like that. I'm not quite ready to give away 32 ETH to get locked up quite yet, but
yeah, absolutely. Well, I think that that's one of the things we'll dive into for sure, is this differentiation between the prior system, the soon-to-be prior system, which is that you could have any computer running, though, for you to reasonably have a chance at solving a block, you would have to be using what are called ASICs, which are these like super specific types of processors that really do almost nothing else. They don't really even have like a monitor port. You can't even play tic-tac-toe on the thing. All that it can do is it can hash transactions and build blocks, versus the proof of stake system, right? And you were just talking about how you have to have 32 Ethereum just kind of laying around and available, and obviously that's not something that everybody has, just laying in their cold wallet. Before we go all the way into that, though, I'd like to take a little bit of time and kind of like rewind the clock, right, and get into a little bit to blockchain basics. So when we talk about how a block is formed in the first place, and going off of the kind of Bitcoin as the canonical standard, you have what's called the mempool, and that's a bunch of transactions that are waiting around to be processed. And then the miners, what they will do is they will organize those transactions and take a certain number of them, and they do a bunch of hashes, which are one-way mathematical operations. Rounded off, though, and from a less technical point of view, you could say that they are creating signatures that validate those transactions. And as those signatures accumulate, there's kind of one signature at the top that is a proof of all the signatures that came before it. And the one transaction that they put into the block at the tippy top of that block is, and pay me what would be the block reward. So at one point in time, at the start of Bitcoin, it was 50 Bitcoin was the block reward, right? So the top transaction in that block would be pay me 50 brand new Bitcoin out of thin air. And that's the mining part of cryptocurrency mining, right? Is that you're doing all these transactions, you're verifying all these transactions, and the tippy one is, and pay me for doing that work. And if your block is accepted as the new block, then you get that reward. And that's kind of the virtuous cycle of working in a proof of work system. The challenge of that, of course, is that it's not just you building that block, it's you and 100,000 other computers all trying to compete for which block gets selected as the new block at the head of that blockchain, right? And if your block is not selected, and you have like an over 99.9 however many % chance of it not being selected, you and all those other the rest in that 99%, all of your work was for naught, right? You put in all that effort doing the hashing, is your electricity got spent, and then it just gets thrown away. And this, in Bitcoin, this happens every 10 minutes, right? Like that's kind of their block cycle. In Ethereum at current, it's a really similar kind of cycle in their proof of work system. It happens to work on a variable close to 13 and a half or some odd seconds. So it happens more frequently, right? But it's still just as wasteful that you have all of this work where everybody's competing to mine the block, and yet 99% of it is never put to use. And that happens every 13 or some odd seconds, right?
Yeah. Yeah, I mean, I think somebody said it's like the entire energy consumption of Switzerland or something like that is being used, just by Bitcoin. There's all those, crazy statistics out there about it. There's an analogy that I saw that I really could kind of like, help envision this is just like a race. Everybody's lined up at the start line. The firing pistol goes off. Everybody's running as fast as they can to get to the finish line. And only one person wins.
Yep.
But nonetheless, like everybody is exhausted, right? Everybody expended energy. And so there's got to be a better way, right? So that's
Mm-hmm.
where proof of stake came out of.
Yeah, exactly right. Yeah. So why does proof of work require this competition of effort? That's, I think, the fundamental to this question of like, why are we capable of moving to proof of stake? So in the proof of work world, you have to have that competition so that it keeps each other honest in an otherwise 100% trustless system. I don't know you, you don't know me, and we don't know the other 99% of the operators out there, but we all need to be able to work together and agree. And the only way that you can do that is by having this competition for acceptance, right? And what's being imagined in this proof of stake scenario is to say, you still don't need to trust me. You just need to trust that I put money on the table, that I'm going to operate in an honest manner. And if you catch me operating in a dishonest manner, you can take away some of that cryptocurrency that I put on the table as my show of good faith, right? And that fits into this overall concept that's called the security budget, right? Is that you can either work really hard with your computers and have them exactly do this race, like you say, or you could work a little bit less hard and have everybody agree that putting that cryptocurrency on the table as your stake is your promise to deliver good work, right? And then there's an incentivization as well to police each other, because you want to catch that person. If they ever are acting dishonestly, you'll get rewarded for having caught them. So that it just kind of shifts the perspective a little bit, but it's one that's been proven out. There's plenty of other blockchains that already exist in a proof of stake, system, and we've seen a lot of different dynamics around that, right? I want to think Polkadot uses that, Solana uses that, Cosmos uses that. Yeah, exactly. I think the list goes on and on. So proof of stake is not something invented out of thin air at this point. There's been whole blockchains that have been operating this way for now, what, years? I think that the other questions that we have about, this movement of proof of work to proof of stake is, what are the total set of benefits, right? Like we've talked a little bit about how the operators change their attitude of like, we all need to race against each other, versus in proof of stake, it's a round robin selection, and we can rely upon the stake that you put on the table as your show of good faith. What are some of the other kind of ways that this changes?
Yeah, one thing that I can see benefiting from it is scalability. So like you were saying earlier, there's a hardware, kind of like a barrier to entry with the hardware, because you have to have specialized hardware, where in theory with proof of stake, you could run it on, pretty simple hardware, because most of it's software based.
Mm-hmm.
There's some caveats to that, like, you'll get penalized if there's downtime while you're a validator, and things like that. So there's still a little bit of a risk there.
Mm-hmm.
But yeah, it's also extremely energy efficient that way too. I believe it uses 0.05% of the amount that proof of work takes. So 99.95%, less energy consumed. So I think that's also going to really turn around the public perception of Ethereum too, because you're talking about NFTs and the tip of the iceberg earlier, and that's something that I really believe in too. It's like NFTs to me are so much more than just pictures of apes and stuff like and cats. I'm ready for the day that like my car is on the blockchain and I can transfer it. So, but right now you talk to somebody that doesn't really know a whole lot about Ethereum and blockchain and NFTs, and they think, oh well, that's like using a ridiculous amount of energy and it's not eco-friendly and stuff like that. So I think this is also a step towards changing that public perception of it. So I'm excited about that also.
Yeah, absolutely. I think that we do see a lot of kind of corporate social responsibility. That's, at least inside of the US, that's something that is a dominating theme, I would say. And that goes all the way to like, whether or not you buy from Patagonia, there's whole brands that have built up their identity on their sustainability aspect. And we're seeing more folks apply that as well to our computing. I'll argue that it's applied unevenly. Like, not as many people complain about the amount of energy that it takes to operate YouTube, for example. But
or those electric cars, right? Like those batteries,
yeah.
Mining the ore that goes into those batteries and shipping them overseas. Like,
yes. So there's exactly, I think, these counterpoints that we can look at, where, we can kind of say, well, it seems like we're applying a measuring stick a little unevenly here, but a nascent field, I would agree, does need scrutiny, and I'm really glad to see that there is public scrutiny around cryptocurrency as a whole. I think it keeps us all more honest. I think that a little bit more that we talked about the energy use. The other thing that I noticed that I think is going to change is, instead of having variable time for the blocks, we're actually going to have a lot more fixed time for the blocks. And the reason behind this is, when you have a proof of work system, you're constantly changing the difficulty of the effort that's made to create those blocks based on the number of participants. So at any given time, you don't know when a network outage or some other event is going to occur that could take a lot of the miners offline. And so you have to have this variability in your difficulty, so that you're not making it too hard and suddenly it takes like 5 years to mine blocks because you don't have nearly enough people operating in the system, right? It's always this trade-off of, speed of the network versus the security of the network. And that's why the proof of work system is like, you don't get a block on a regular interval, you get it on a mixed interval based on the prior blocks. Pretty complicated stuff. But the base idea is, going back to the Bitcoin example, you want the new block to emerge roughly every 10 minutes, right? But if it suddenly changes to where the prior, 2, 3, 4, 5 blocks have taken 15 minutes because there's not enough miners, then you may find that the difficulty will go down to encourage more miners to participate, or for them to be able to solve the blocks a little bit faster. And vice versa. So if we're solving blocks a little bit too quickly, we'll see the difficulty increase to kind of slow them down. But it always causes, the net effect is that the blocks are created in an uneven interval. And with proof of stake, because you know who's going to solve the block on this, very straightforward round robin system, you also don't need to have nearly the same amount of variability in the difficulty. You can actually have a fairly static form of difficulty, and it allows your blocks to come out in a much more organized fashion. So we should expect the Ethereum blocks post-merge to be coming out every 12 seconds or so. Yeah. Getting back to your earlier point, you were saying that the kind of energy and computing requirements are lower. You're absolutely right. If we look at the ETH staker community, for example, they're a really great community to look at. Superfizz on the regular has people kind of showing off their machines that are being used for the post-merge blockchain, the beacon chain. And very often it's an Intel NUC. And for those of you who don't know, these are really small devices. They look almost like an Apple TV sized device. It's not a big and beefy gaming rig or, any more exotic hardware than that. It's really just this very basic machine. Some really extreme folks I've heard of getting it to run on Raspberry Pi as well. I'm not that adventurous, but I'm definitely thinking about this idea of using something like an Intel NUC that could be a dedicated machine. It could live in your closet, and yet it's there and capable of helping to secure the network and ultimately earning rewards for doing so, which is fantastic.
Yeah, I'm really curious actually, because I do a little bit of like DeFi investing as well. So, these like hardware specific miners, people have huge operations in like Iceland and Norway and stuff like that. So I wonder if the merge means a lot of different things to different people, right? And I kind of feel like that probably means almost like an end of an era to these sort of people that have dedicated their lives and money to building these machines and buying like plots of land in other countries and stuff like that. And I'm just curious what the like long-term economic sort of repercussions this might even have,
Very much a good call. I think that there is an impact to miners. We also saw another impact to miners earlier last year with EIP 1559, right? And that changed the way that rewards are doled out in the current system. And when we look at those two things combined, I think we could see either that the miners have to shift to an entirely different coin that's using a similar hashing algorithm, or they would dump their hardware entirely and just not participate anymore. Another point in time when we saw this kind of like major shift in miner activity was in China, but that was more related to them kind of banning the mining of cryptocurrency and more specifically the use of their renewable resources, right? They had a lot of these hydroelectric power stations, and almost the entirety of the energy generated was going to these mining rigs. But we did see this major shift in miners, according to legislation. Now I think we'll see a major shift in miners as well, but that's more to do with governance. So it's a changing in the rules, but just one that was established collectively by the participants in the system.
Yeah, and I hear rumors about miners wanting to do a hard fork of Ethereum and create Ethereum POW, and there's even and I don't really know how it works exactly, but there's an IOU out for it where you can already trade like your old Ethereum, and it's only like $50 a token or something like that. But so we'll see how that goes. But thankfully, like Tether, or Circle, and like Aave and OpenSea, all the major players in the space have already like confirmed publicly that they're going to stick with the true Ethereum, blockchain. So that's good.
Yeah, exactly right. I think that there was also a major source of confusion for people. Some folks thinking that this proof of work Ethereum fork would somehow give them double Ethereum or these different things, and that's absolutely not the case. A fork really means a different network, right? It's a different computer network, a different ledger that's tracking transactions. And it's very good, like you were saying, that these participants were just calling out early which ledger they're going to honor in terms of the work. So yeah, it's really fascinating. I'll be really interested to see what happens with this idea of the proof of work fork, and whether or not that really holds up, or whether or not folks find a better opportunity in a different chain entirely.
Yeah.
One thing that I wanted to talk about a little bit as well, because we were talking just briefly about EIP 1559 and how this relates to the miner community. I also wanted to talk about issuance in general, right? So that's one thing that may or may not be well understood about this particular move during the merge. But if I'm understanding it correctly, there is going to be a triple halvening event that occurs with the merge. And if you could, I'd love to hear your take on, what is a triple halvening and what does that impact the folks?
Yeah, so essentially, Ethereum is going to, over time, become a deflationary token. So there's going to be less and less of it in the world. Yeah, you're right. So whenever a transaction is validated, there's one validator. They get the transaction fees, and then there's other validators that attest to that validation, and they also get a little bit of reward. And there's some equations online that break down exactly how that's paid out. But yeah, the triple halving, it'll be over, forget how many years exactly. I'll have to double check, but that's another thing that is going to probably affect the kind of like the price of Ethereum over time as well. And a little bit is also burned in the transaction. So from what I understand, I'm a little fuzzy in some parts of it too, but a little bit of Ethereum is burned and a little bit is created, and it just sort of, the amount which is burned slowly makes it more and more deflationary over time.
Yeah. So going back to the Bitcoin example, I kind of talked about early in the early days of Bitcoin, a miner would write that transaction at the top of the block saying that they got 50 Bitcoin for solving the block. The halvening means that would be cut in half. That block reward would be cut in half. So that's 25. And if you cut it in half again, then that's like 12 and a half, right? And then if you cut it in half again, then that's like 6.25. All right. So a triple halving, if you go from 50 to 6.25, that's almost a 1/10 reduction, right? Or I should say a 90% reduction. That is a similar thing is going to happen in Ethereum, where instead of the block reward being something like 4 ETH now, I think 4 point something ETH, we'll see that cut it in half again, and cut it in half one more time, which actually makes the block reward quite small. But as you said, there's transaction fees. And transaction fees are just kind of like what you'd expect if anybody's transferred money in a bank, right? If you've done a wire transfer, usually they tack on like another $75 or something like this. That's the fee that the bank takes for moving your money from, your account to your friend's account or whatever. So you accumulate, 100 of them or so. That's actually a pretty good chunk of change. So that's going to be the real reward more than the actual block reward over time. And you're right, with 1559, that was the network improvement that happened last year. Half of the amount of Ethereum that would be rewarded gets burned. So yeah, it's not so much that new Ethereum is being generated, it's that more often it would be expected that the blocks would burn more Ethereum than they would mine. And the real value is coming from the transaction fees.
Yeah, like I think there's going to be a point probably like in the future whenever, I've got like great grandkids or something like that. And then not that they'll probably be this nerdy, hopefully they are, but they'll be like, remember back in the day whenever you used to mine a block and you'd get a little bit of Ethereum, not just the transaction fees. Those are the good old days. So
no, absolutely. And like we were saying, deflationary, what that means is that the total amount of Ethereum that exists will actually be less and less over time. So an example I like to give folks that's a much more less technical example, but imagine there's a gold mine and the gold mine says, hey, every single day we tend to generate 100 grams of gold. And then on a different day, they say, hey, we are from this point forward only going to generate 10 grams of gold. You would naturally expect then that the value of gold would go up accordingly just because of reduced supply. Now what we're saying is not only is it going to be 10 grams of gold, but 11 grams of gold on any given day is going to get shot into space. and it's just not going to be around on planet Earth. So once again, the total supply is going to dwindle, right? That's, I think, really revolutionary, and it's going to be really, really fascinating to see whether or not these kind of supply changes can overcome the macroeconomic environment, right? In 2022 of September, we see a lot of things happening in the world in terms of, overall markets, energy, and whatnot that have all had a rather negative effect. And it'll be really curious to see over the next couple of months whether or not the merge has found a way to kind of decouple from that overall macro trend.
Yeah. And you were mentioning gas fees and transaction fees and things like that. And I think that's two things that are a misconception about this merge specifically, is that that'll make gas fees less and it'll make Ethereum faster. Because I'll get asked that every now and then. They'll be like, okay, this is exciting, triple halving, proof of stake, but it'll make gas fees less, right? So whenever I go buy my expensive NFTs, it'll be significantly less expensive. And the answer to that is no. Those transaction fees still go to stakers instead of miners. And I think as of right now, from what it looks like, Ethereum is still relying really heavily on layer 2 solutions to take some of the brunt of that. And then as far as like making things faster, from what I understand, there's also something on the Ethereum roadmap for next year, presumably, Sharding, which is going to turn Ethereum from a one-lane highway to like a multi-lane interstate. This should somewhat address that as well.
Exactly right. So I think you're spot on that it's not going to get any cheaper to buy or sell NFTs. on the Ethereum mainnet. That's not really related to the merge at all. And that we are seeing other what are called layer twos, like the Polygon network or Arbitrum, picking up the slack, so to speak, and allowing for transactions to occur, but you're still using an Ethereum address, and attestations from those networks are coming back to the Ethereum mainnet. So I think that you're right. Like, if folks are thinking about what would be more affordable opportunities in NFT production, it probably is wise to look at some of the layer two solutions if you don't want to have your clients and be involved with like the heavier gas fees and competing for the more rare spots in Ethereum mainnet blocks.
Yeah.
Excellent. I'm kind of curious about, as we move from proof of work to proof of stake and this whole merge, what are the kind of changes that we might see in terms of development? Will it really have an impact on like you, 236 as a whole, in the way that you create smart contracts and deploy them? Is there anything that you'll be changing about your kind of like QA and development practices?
Yeah, honestly, I looked into this and there's nothing that I can immediately like foresee impacting as a business. Because that's another question that I've gotten before too. They say, well, what do I need to do to prepare for the merge? Do I need to send my tokens to this address like this Discord bot asked me to? Or, will I be getting extra tokens or, questions like that? And the answer is honestly right now, you don't have to do anything. That's the great thing about it. They made it, I was watching a interview with Vitalik and Lex, kind of like you were earlier today. And they tried to make it as fluid as possible going forward. So they had the option to pretty much dump all these changes at once, which would have been scary and kind of jarring to the user base. And then they decided that they were going to roll things out, which is, of course, the smarter way to do it, one little piece at a time and kind of getting people slowly acclimated to things. So thankfully, this does not involve, this has no breaking changes in our smart contracts. It doesn't affect really us as a NFT minting sort of contract way.
Excellent. I'm kind of curious, were there any other major changes that you see coming as we move from proof of work to proof of stake? Any other things that we should be keeping an eye out for?
Yeah, as I mentioned earlier, there's sharding that seems really interesting. I haven't gotten the chance to dig into it a whole lot lately, but it's going to be using fractionalization in a way that's going to, like I said, open up the kind of like Ethereum transaction pipeline from a single lane highway to multiple lanes that should hopefully make things a lot more accessible as far as transactions go. And I think that's kind of what's one of the big pieces missing from this puzzle right now. You see conventional transactions like from Visa and things like that. And Ethereum really just doesn't compare to the transaction speed. And you kind of get this trilemma that you see with like a lot of projects. You've got cheap, secure, or fast. And right now, Ethereum does secure really well. I think that's kind of where they really hit the nail on the head. And then they're leaving it up to more layer two solutions to do the cheap and fast sort of route. But I think their goal is to eventually move forward close to a faster Ethereum as well to just kind of raise the entire ecosystem. That's kind of how I see this thing. It's just a platform for everybody to build on top of. Sure, there's going to be problems, but that's sort of what layer two solutions are all about.
Absolutely. I think the other thing that I see out there on the horizon, and it's quite a ways out, is this concept of proposer-builder separation. So before I was talking about how there's this mempool and the transactions are organized into blocks, and then that particular block is proposed as the next new block. The idea was you can separate the responsibilities a little bit. There can be one person who organizes the transactions in the block and a separate person that proposes that block. And the reason why that's important is that will help with helping to diffuse risk around censoring transactions. It'll make sure that there are a lot more equitable players that will allow for any transaction to go across the network. And there is currently this thing that's called MEV, which is a way of ordering transactions to extract the most amount of value from those transaction fees. And what we could see is a more level playing field about how those rewards are distributed amongst the participants at the validator level if we're using this concept of proposer builder separation. So yeah, I'd be really interested to see how both sharding and PBS kind of work out in the future.
Yeah, definitely. There's a lot more to the roadmap. Their website has a lot of interesting stuff on it. It's pretty dense with technical knowledge, but it's interesting to look to see where we might be headed, from a crypto standpoint.
Yeah, absolutely. And, Matt, I just wanted to say thanks again for coming on the podcast and being able to talk about the merge with me. I think as we come to these other, major changes in the network, it'd be great to have you back, and we could maybe talk about sharding the next time as that goes live, or PBS as that goes live.
Yeah, maybe do a live stream as a proof of stake goes live.
Yeah, absolutely. And for the folks who are in Austin, Texas next week, I will say, come on by Thursday night. We're going to be having a merge party. Excellent. Well, thanks again, Matt. It was really awesome having you on the podcast.
Thank you. Appreciate it.